Welcome to a lesson on the effective rate of interest, or effective yield. The goals of this video are to know the effective rate of interest formula for compounded and continuous interest, and also to determine effective rate of interest. The effective rate of interest for compounded and continuous interest is the equivalent annual simple interest rate that would yield the same return after 1 year. Remember, simple interest pays interest once a year. So we should already be familiar with the compounded interest formula given here and the continuous interest formula given here. So to determine the effective interest rate, we have a formula for compounded interest as well as continuous interest. The effective interest rate identified by R sub e for compounded interest is equal to the quantity 1 plus r divided by n raised to the nth power minus 1. And for continuous interest, we have r sub e equals e to the r minus 1. Before we actually use these formulas, I do want to show where they come from. So for the compounded effective interest rate, we want to know the simple interest rate that would yield the same return after 1 year as an account paying compounded interest. So if we set the simple interest rate formula here equal to the compounded interest formula, we want to solve for the simple interest rate, which would be r sub e. But remember, r sub e is the simple interest rate after 1 year, so we know t would have to be 1. So if t is equal to 1, we can rewrite this as p times the quantity 1 plus r sub e raised to the first power is equal to p times the quantity 1 plus r divided by n raised to the n power, again since t is equal to 1. And now to solve for r sub e, we could divide both sides by p. This simplifies to 1, and so does this. So now we have 1 plus r sub e equals 1 plus r sub n raised to the power of n. And now we just subtract 1 from both sides of the equation, and we have our formula for effective interest rate for a compounded interest. R sub e is equal to the quantity 1 plus r divided by n raised to the power of n minus 1. This is the same formula that we saw on the previous screen. Let's go ahead and derive the formula for the effective interest rate for continuous interest. Again, we set the simple interest formula equal to the continuous interest formula, and we want to solve for r sub e. Again, we know t is equal to 1 or 1 year, so we can start by writing this as p times the quantity 1 plus r sub e is equal to p times e raised to the power of r. Now we'll divide both sides by p. So on the left we have 1 plus r sub e is equal to e to the r. Again, subtract 1 on both sides of the equation, and we have the effective interest rate formula for continuous interest. We have e to the r minus 1. Now that we know where these formulas come from, let's take a look at two examples. We want to determine the effective interest rate for an account paying 4% quarterly compounded interest. Well, the interest rate is 4%, so r is equal to 4%. Expressed as a decimal would be 0.04. And because the interest is paid quarterly, n is a number of compounds per year, so n is going to be equal to 4, since there are 4 quarters per year. This is all we need to determine the effective interest rate. We have r sub e is equal to quantity 1 plus r divided by n, or 0.04 divided by 4, raised to the power of n, which is 4, minus 1. Now we'll go ahead and go to the calculator and get a decimal approximation for this. So we have 1 plus 0.04 divided by 4. We want to raise this to the 4th power, and then subtract 1. We'll go ahead and round this to 4 decimal places, so it's approximately 0.0406. To convert this to a percentage, we multiply by 100. This is going to be equal to 4.06%. So this is the annual simple interest rate